Hello again. I hope that you enjoyed the networking session or you had the time to get some break. Ahead of us, there is like a 2 hours long workshop session. I think the first workshop during this conference. It will be really interesting. Delivered by Krystian Igras, our Shiny developer for a pharmaceutical company. He will present us the shiny, powerful web apps for everyone. And there are at least two strong indicators that will be a really good quality workshop. So first one is that Krystian is doing trainings in Shiny and R for years. And the second one is that I have this privilege that I've worked with Krystian for a couple of years, and I know that he knows what he is doing in the Shiny applications. So yeah, I'm expecting really good quality. I had previewed the repository, and there is an interesting stuff there, starting from the very basics to some really nice concepts and topics in the Shiny. So yeah, please welcome Krystian, and yeah, the floor is yours.
Yeah, thank you, Martin, for the introduction. Welcome everyone to my workshop. Yes, the workshop is about Shiny powerful web apps for everyone. So you may think that together today we will be building the Shiny application together, and yeah, you're right. So before we start, let me present you a short demo of the application that we're gonna build today. So let me share the screen, and yeah, and let's run the application. Yeah, so this is the application that we're gonna build. So today you could see something similar during the talk of Aaron Clark. This is the application that helps you to build the random data. So what we can see here is like the sidebar in which we can provide the number of rows to be generated. We can provide the name of the variable. So for example, we can create the variable named age. We can select the type of the variable over here. So for example, integer, and decide whether we want to generate uniformly from the selected range or from the specific distribution. We've got binomial here and Poisson. Let's choose binomial. So the configuration is ready. Let's put something else, for example, ID. This is the character variable. We can see the number of letters. We can select number of letters. So let's say it's always 10 and some pattern. So we only use capital letters. And another one. So for example, height. That will be the numeric variable. So from the normal distribution, for example, with some parameters. And yeah, there is a typo, so no problem. We can fix it over here. What's more? Let's do something else. So for example, if we're generating the data regarding the patients, this is an important indicator whether somebody is smoking or not. And we create the custom variable with providing our custom code. So if we do something like this on the production, you can be fired. So don't do it. But just to present that something like this exists, or just for local purposes, we can just pass some code over here. Why shouldn't we do it in production or even publish such application to Shiny apps? That's because it's very dangerous. Somebody can steal our data, for example, from here. But for our local purposes, let's do it. So let's create some R code over here. We use sample from the vector of length 2, yes or no. We use the specific variable over here, n rows, that is like the number of rows to be generated, and replace true to be able to do it. And so we've got 4 variables defined, and then we click generate, and the table is here. What more can we do here? Or for example, download the data into the CSV, the table into the CSV, Then we can like modify, maybe we don't want ID, so let's remove it and generate again and download the table. Yeah. Okay, so this is something that we're gonna build in this 2-hour workshop today. How can we start? In order to start, please open the link to my GitHub repository, Shiny Conference 2022. And the easiest way to actually start is to download the content as a zip. So if you open the GitHub, you click code dropdown, and you download the zip file. Then if you're in the correct directory when you've saved the zip file, you can just extract it, and in order to start, just open Conference Workshop R project. This should open you the R Studio. All right, so let's wait a few seconds until you get the code. And I will tell you soon about the structure of this repository and how are we gonna work together. But before we do it, I will ask you to install the required packages. If you have all of the packages, then it's okay, you don't need to do it. If not, then just simply run the whole block of code. You can see some well-known packages over here, like Shiny, DT, HTTR, Glue, dplyr. But there is also one exceptional way of installing the Shiny Gizmo package. This is the fresh package. It's already on CRAN, but I did some improvements that will be useful for our workshop over here. So please install it from GitHub. So the last line of code will allow you to do it. Okay, so if you run the installation, so now I will tell you how are we gonna work together. So there are 5 blocks of content over here. So the first one, the second one, and so on, and each block ends up with the exercise. So before we start the exercise, I will go through all of the scripts over here, describing you some Shiny techniques, presenting some useful functions, and then you will just you can also run it, test it out along with me. But at the end of each block, you will have some very simple basic tasks that are using the topics that I discussed earlier. Okay, and yeah, if you don't want to do the exercises, you just prefer to watch, then you can just simply jump into the first application in each block, which is actually the solution to the previous exercise. So you may choose whether you want to try yourself with testing the learned functionality, or just go straight to the example. And what is the way of this exercises? In each exercise, we're gonna build another functionality that will make our application closer to the one that I presented you before. So when we finish our exercises, we will have something like what I showed you before. Okay, so all right. One more thing. I planned each block for around 20 minutes so that we can be on time. But if we cannot do it, like we run out of time or we need some more time for some of the blocks, then there are some optional parts in the latest block, in the 5th block. So at least I will leave you this as a homework. Or you can chat with me later if you have any questions regarding those parts. What is more? Oh, yeah. If you have any questions, just write them on chat. Marcin will be supporting me, so he will be answering your questions. I will also be looking at the chat so that if there is something like there is some straightforward question that I can quickly answer to, I will do it. All right. One last thing, like the request from me, when you finish your exercise, please send a thumbs up on on chat so that I know that you have already finished. So if I realize that there are no many time gaps, then maybe I will just wait more until you finish. Okay. I think that's it. So let's start with Shiny applications. So what can we see in the first script, the structure.r script? Is the most basic, is like the boilerplate of Shiny application. And what we can see in here is like loading the Shiny library, defining the UI with the fluid page. So the UI is actually the structure of the initial structure of our Shiny application. So we can put it some text, some blocks, some input controllers, everything that we can see on the application. That is not initially dynamic, but I will explain it later. Let's see what actually this UI returns. If we print the UI object, we can see this is a simple div block with a proper class that is used as a basic container for our Shiny application. We will run this application soon, and we will see how does it affect our application. Then we define something like server. Server is the function of 3 parameters: input, output, and session. Within the input, we store all the user input values. So later on, we will be adding some input controllers. The user can select some values, and all of the values will be stored here. So we will be referring to this object to get those values. Output is the specific object in which we store our custom outputs that will be displaying on the Shiny application, like for example plots, tables, and so on. And the session object is a little bit more complex. It stores some user session specific information. It is mostly used for communication between the Shiny server and the browser. We will see some examples later. Okay, if we want to run the application, we use Shiny app function. As a first parameter, we put UI, generated UI. As the second parameter, we put the server, and we run the application. Okay, we can see nothing because we haven't defined anything yet in the application. But if we look at the website, the generated website source, we can see some of the code is already included here. We've got the head block. Maybe I zoom it. Head block in which we store the most basic dependencies that Shiny is using. So for example, we can see Shiny is using jQuery. This is the JavaScript framework. And for styling, Shiny is using Bootstrap. So we can, for example, here see the Bootstrap means CSS. But the most important part for us for now is body. This is that block of code of website structure, of application structure, and we can see the familiar code we saw before. This is exactly what our UI is, and everything that we place inside of the UI will be there. So let's do some modifications over here. So let's put some plain text. Let's put some h3 object. This is the level 3 header. So this results with increasing the font size and font weight of the text that we put inside. And we can put even our custom div objects with some maybe ID and some text over here. Hello. Yep. And when we run this application, we can see that something finally happened. Something finally showed up in the application, and we can see the page source and exactly the code that we've generated is included here. So this is the most basic knowledge you should need in order to start with writing the Shiny applications. There is one tricky thing in RStudio. If you don't want to create this boilerplate from scratch every time, you can use the snippet. So it's writing Shiny app and pressing tab. You just get it. Yeah? So it's much easier to start. But If we want to build like some complex application, then we usually need to start with building the layout. And we sometimes need to have the imagination, need to know maybe CSS to build some layouts. So we would like to use something that is ready. And with Shiny, we've got some ready layouts that you can see in this link that I've put here. The one that we are gonna use is the most standard one. It's the sidebar layout. Sidebar layout is created inside the UI with sidebar layout function that we can see over here. What it does, it actually divides our application into two columns. By default, the left column is our sidebar, which we create with sidebar panel function. And the second one is the main panel, which is the main content of the application, usually placed on the right. Let's check. Of course, inside sidebar panel and main panel, we can put anything we want, like some titles, third level header, plain text, some div objects in the main panel. If you run this application, we can see it's already here. Also, we may see that the sidebar panel is already a little bit styled. So for example, it has some background color and some a little bit rounded corners of this block of text. Okay. What's more regarding the sidebar layout? We can, for example, manipulate the width of it. So, for example, we can set the value to 2 to sidebar panel, and keeping in mind that the full width of the Shiny application with this layout is 12, we need to assure that the sum of width of sidebar panel and main panel is also 12. And let's run the application. Okay, as we can see, now the sidebar is much thinner. Here, no questions. All right. Now, if we know how to build a standard layout of our Shiny application, what we may want to do is to actually start gathering some information from users. And the objects in Shiny that are responsible for it are input controllers. So if we open the third script over here, we can see already some of the input controllers that I've included. So if we run such application, we may see that we've got here the action button. So this button is counting the number of clicks of it. Some numeric input where user can put some numeric values, text input, slider, range slider, so we can see the range of some values, and a simple drop-down like named in Shiny slider input, where we can choose, for example, a letter. How do we create such input controllers? How do we do it? So we've got a bunch of functions that do it. So for example, in order to create the action button, we call action button function, and we provide the two obligatory parameters. The first one is input ID, that is the unique ID of this input controller. This is very important that every input controller we have has its own not duplicated ID. That's because later on we want to access the value of this component. The label usually based on the component, based on the controller, is placed either inside of this component, like for example in case of action button, or for example as a label on top of this object, for example for numeric input. And depending on the input controller we choose, we may have a set of some extra parameters or a set of some required parameters that differ between each other. So in action button, it's enough to place input ID and label. In case of numeric input, it's also important to put input ID and label or null value for the label if we don't want to have it. but also some specific values like as parameters, arguments like value. This is the initial value of numeric input. Min, max are optionals, but they precise whether you want to have the limitations for the input values in it. And step, so we can just, while increasing the object in the numeric input, this is the step that is responsible for this increment. And all of the other input controllers are defined in the similar way. So every time we've got input ID and label, and then some other parameters. Like for text input, we've got default value. For slider input, we've got value, minimum and maximum. This is also obligatory for slider input and optional step. In case of having the range slider, it's just enough to specify the default value as the vector of length 2. So the Shiny creates the range sliders if we provide the initial value as the vector. And slider input, in which we precise choices, where we put the vector of some elements that should be displayed in the dropdown. And that's it. So with just a few simple functions, we can already build an application in which we can take some values from the user. All right, so now if we have the knowledge how to build such input controllers, we need to know how to actually take that specific value and use this in the application. So let's open now the script number 4.1.4, observers, and see what's going on over here. We've got two inputs, slider input and action button. The slider input has ID mySlider1, action button has ID myButton. And now, if we want to listen to the changes of those inputs and use them in the application logic, we need to use, for example, observe event function. The function takes two parameters. The first one is, both parameters are some expressions, but whenever we place some reactive values inside of the first expression, and any of those reactive values changes, then the second expression is triggered. So we can see it here. As a first expression, I have used some object input $mySlider1. So what does it do? Input is the object that we have inside the server. Dollar just refers, is just the operator to take the specific element. So from this object. So from the input, we are taking the object with the same ID as we have in slider input. And in this case, this expression is the current value provided by the user. Yep. So whenever this value changes, we will trigger the second expression that is passed to the observe event. We can see the second expression starts with those curly brackets and ends up with curly brackets. And here what we do is actually we print some information, slider changed, and print the current value of our input mySlider1. We can see here the other way for taking the value from input. This is the operator two squared brackets operator, in which we pass the name of the value as a string. This is especially useful for us if we want to have some like dynamic value to be taken. Yeah. So now let's take a look what this application does. So let's run it. Select some number over here, and what happens? Nothing happens because we are printing something inside our console. Yeah, so we print the message slider changed and the value 1, slider changed, value 5. And if we come back to the application, do something else, we can see that this indeed works. All right, so now let's do something else, what we can do with observers. One thing that is very useful is the set of update functions that is attached to almost every input controller that we have in Shiny. So for slider, we've got update slider input. For text input, we've got update text input, and so on. The first parameter for each such function is session, which we just place here. simply. The second one is the ID of the input controller that we have in our UI. And the third, the next parameters are the arguments that we want to update in our controller. So in our case, we just update it with some random value from the set of from 1 to 10. And here we've got observe event, and we're listening to the changes of my button. So the clicks, whenever we click my button, this value changes because it counts the number of clicks, and we update the slider input. Let's check it again. So click, click, click. And what we can see in the console is that whenever we click the button, the slider changed message also is displayed in the server. Why is though? Because when we updated the slider input, the MySlider1, with ID MySlider1, then this value also changes, so it triggers again the observe event that we've had before, and it prints the the following code. So we can see that with such observe events, we can build a chain of dependencies, the reactive chain, the reactive chain of dependencies, and we can build a little bit more complex logic. All right, so this is everything that we need to know for now. And I encourage you to go to the exercise script. Let me explain what's going on over here first, and then there is your time. Okay, so we've got the application that is using the standard sidebar layout. We've got sidebar panel, and inside sidebar panel, we've got some title, table generator, some numeric input with ID my number. We've got empty div block, which we'll be using later. We've got another div block, but it's not empty. It has ID defined vars. And inside, we've got text input with ID name and action button with ID new. Over here, we put some more parameters. So in this action button, we've got ID new, no label, so this is null. And we put some icon with the plus icon. And the width of the element equal to 100%, so it covers the whole width of its container. Then inside of the main panel, we've got nothing. Inside of the server, we've got one observer that is listening to the changes of new button. It prints just in the console new clicked, and it prints also the value of the name provided above in this text input. So that's everything we have over here. And as for the exercise, what do you need to do is to change the numeric input ID so that it's accessible in the server with input $n_row. So you need to provide the correct ID over here. What else? We want to change the initial value of our numeric input to be 50, to be equal to 50. Then we need to create our custom action button that will be accessible in server with input $run code. It has label equal to generate and also covers the full width of the container. So you may use the approach of the existing action button. And then as the last part of this task, of this exercise, is to create a new observer over here that listens to the changes of the button that we created in point 2. And as a callback, so the second expression of this observe event, just print run clicked. And that's everything that we need to do for now. And this is a good start for our final target application that we're going to build together. So yeah, now it's your turn. Please try to implement the tasks, and if you have any questions, just write on chat. And if you already finished the exercise, please also let me know, so I will know whether you need more time or not. And good luck. Okay, I can see some of you have already finished it, but let's wait at least 1 minute more, so everyone have a opportunity to finish. If you have some troubles, you can ask on chat or just look at the solution in the next script. This is exactly what the next application, the next script stores, like exact solution to this exercise. All right, 10 more seconds. Or if anybody needs more time and want me to wait, just write it as well. All right, I think we can move to the next script. So let's take a look at the solution. So what we had to do in this exercise, we had to change the ID of numeric input into n row so that we can access this value inside the server with input $n row. Yep, and change the default value of numeric input with the value parameter and replace it with 50. What's more, we had to create the action button. This action button, it should have ID equal to run, label generate, and its width should be equal to 100%. And some changes inside of the server. We had to add another observe event that is listening to the changes of run button, input $run, simply here, and just prints inside of the callback run clicked. And that's everything we had to do. So now the next step in building the Shiny application, if we already know how to access the input values, how to perform some basic actions based on it, the next step is to display some reactive outputs inside of the application. What can be such outputs? For example, the charts, tables, or text. What else can be, for example, some dynamic HTML, like the dynamic content. Yeah. So how can we achieve this? Let's take a look at another script, renders.r, and let's run the application first. Okay, it's here. So what do we have in the application? We've got 3 inputs in the sidebar. The title, let's place something here. Find function. Yeah, it displays correctly in the plot. We've got some maximum x-axis value. So we can, for example, place it to 1. We can place it to 19. We can place it to 20. So we can see that the chart that is displaying here the sign function in a range of its arguments from 0 to 20. And the 20 is the dynamic value provided here by the user. What else can we do? We can provide the information who generated this chart. For example, it's Krystian. And we cannot see it. We need to scroll it down. It's generated here. In order to see it better, we can, for example, make it this value smaller. Maybe let's change that. Zoom in. So, for example, Krystian Igras. Yeah, we've got the dynamically generated text over here. We already can see a lot of things that can be improved here. So, for example, this table shouldn't be here, or at least shouldn't display all of the rows of the data that is displayed, that is used for the chart. But those improvements will be done later. Now let's learn how to create such dynamic output. So we load Shiny and a glue package that we will be using later. I will present you its functionality. But what do? We've got the UI with the sidebar layout. In sidebar panel, we've got everything that we already know what is doing, some text to text input and numeric input. And if we want to generate the dynamic output in the Shiny application, we put inside the application UI information like the placeholder that we want to generate the dynamic chart or dynamic table in this specific place. So in order to create such container for this output, we use plot output for generating plots, table output for tables, and text output for texts. So very simple. And as a first parameter for each such function, we put some ID. This ID should be also unique, and we will be using this in the server. So now, if we want to generate the plot, we need to create the object of the same ID as in this container inside of the output object. So we can see that the second parameter of the server is output, and if we want to create the output, we create the we assign to output dollar and the ID. So for example, sign over here. And in order to generate, in order to provide what code should we use to generate the plot, we use render plot function. Inside of render plot, we place the expression that is responsible for generating our chart. So in here, we can see we generate the plot data. It's the data frame of two columns, X and Y. The X is the sequence from 0 to the input value provided by user, input $xmax, because this is the ID of this input. More to that, we create as a Y, we convert the same sequence with sign function. And with such data, we use the standard rplot function. It's named plot. On X variable, we use plot data $x. So this is an X variable from the table. As on Y-axis, we use plot data $y. So this is the second column, the Y column from the table. As a main parameter, we place input $title. Main in the standard plot is the responsible for putting the title to the chart. So input $title is just the first input that we have in this text input. And type L for just generating the line plot. And with this render plot function and this code, we generate plot that is dynamic, because every time that some reactive values like input $xmax changes or input $title changes, this code is rendered, executed again, every time some reactive value changes in this expression. So that's why we generate the dynamic plots. The same thing, it works almost like exactly the same for rendering the tables. We generate the plot table object inside of the output. This is exactly the same name as we've used for the container within table output in UI. We generate the same data, and instead of returning plot, we just return data frame over here. So it's the table to be rendered. And for the last part, when we output the text, dynamic text, we use render text function. Of course, the same workflow. We generate the output element named gen_by, because this is the ID of text output. And here we use glue function that is used for text interpolation. So, for example, if we have the variable name Krystian, yes, and we call this block of code, but in the curly bracket we place the name of the variable, this variable will be evaluated and replaced with its current value. So chart generated by Krystian. And instead of the name itself, we are using input $generated by. So this is the text input that we have in the sidebar, the value of the text input that is placed in the sidebar. And if we run this application, then we have the output that we wanted. So yeah, the title is here, works, generated by, we need to fix it soon, works as well, yep. So so it's very simple and it works. Now, you've probably already realized that this application have some drawbacks. So let's run this application and try to, for example, change the value of maximum x-axis value. And in order to place, for example, 30 over here, we need to remove the value over here, and we can see some red messages in our application that tells that error 2 must be finite number. So a lot of errors we cannot accept it. So we need to know how actually can we validate the inputs, the user inputs, to decide whether we want to generate the output or not. So let's open the next script. And what do we have over here? We've got the same application, even simpler. We've got only numeric input, we've got plot output and table output. Let's run this application and try to remove the value over here. We can see that no errors are returned. We only see as grayed out message, no valid data, displayed instead of the plot, and we actually cannot see any output message for the table. So how can we achieve such behavior? We can use two approaches. The first one is the connection of validate and need function that we place at the beginning of render function. So inside validate need, as a first parameter, you put the expression that needs to be true in order to generate the code that is included after calling the validate need. So whenever input $xmax, so the value provided by the user is greater than 0, we will just generate the plot. Yeah, so we will execute this block of code. Otherwise, if the condition is not met, we just display the message that we put as a message parameter. So no valid data. So this is one approach to validate whether we want to display something inside of the render function. The second option is a little bit simpler. This is the simple rec function, in which we just provide the condition. And if the condition is not met, the similar thing happens. The code the code under the rec function is not executed at all, but instead the render function will return an empty object. So no message will be displayed, nothing will be displayed actually. Yep. So this is a very simple, those are the two simple options. How do we validate our output? How do we take care that no error messages are displayed on our Shiny application and so on? Yeah. So this is it about the validation. And now let's take a look at our server function of the application that we have. We can see a lot of code duplicated code. Inside render plot, we can see that plot data is generated. It's like generated from scratch. We generate data frame over here with two values. Then we use that object to generate the plot. But the same thing happens in the render table. So what if we just decide to use this as a common object and place it directly to the server? Okay. So we place it directly to the server, the plot data, and then let's remove it here. We don't need it anymore. Yeah, the object will be created over there, and let's try to use it. Run, and yeah, crash. What happened? The Shiny tells us that the can't access reactive value xmax outside of reactive consumer. So that means we tried to execute some reactive operation outside the reactive context of the application. And so we placed it directly in the server, and Shiny doesn't allow us to do it. We need to inform Shiny that we want to create the object that is reactive. So there are at least 4 ways for doing so in Shiny, but I will present you only the one method that I like the most, and that is very straightforward method and useful. So reactive value. If we want to create such reactive value, we need to first initialize it, and we use for this case the function reactive value from Shiny. As a first parameter, we place the initial value of this reactive value. So let's over here we create rval, that is the reactive value, and put something here. So this is the initialization of this reactive variable. Later on, if we want to use the value of such reactive value, we call it without any parameters. So this is very important. We cannot access this object value just using this object. We need to call it without any parameters. So this is taking the value from it. And we reassign the value of this reactive value with calling this object with some new value provided as a first parameter. So very simple. And let's see it in action. So over here in the server, we generate the plot data reactive value with its initial value null. Then we need to decide when do we want to update this reactive value. When do we want to recalculate the data? We actually know when we want to do it. We want to do it every time the xmax input object, so this is the object that is specifying the maximum x-axis value, whenever this object changes. So we create observe event, listening to the changes of xmax, and as a callback, we define the code for generating this table. So if the input xmax is greater than 0, then we generate the table and update our reactive value with this table. Yeah, so this is our new created data frame with the new range, and we update this with calling the reactive value with new value inside as a first parameter. Otherwise, if this condition is not met, then we just reassigned again the null value to our reactive to our plot data, this reactive value. And inside the render plot, we create the validation. So use validate need, and we check our condition is to have this value not equal to null. So we check, we use is null function to check whether the object is null, and we put the negation to it. Yeah. So whenever the object is not null, we execute the code for generating the plot, and remember to use the value of the table with calling it with the brackets, yeah, without any parameters. So in order to access the x variable, x column, we type plot data, open the bracket, close the bracket, $x. The same for y. And inside render table, we do the same. Yep. So also we check whether the object is not null, and we plot the data. Plot the data with taking the value of plot data variable. Okay, and it should work as well. Yeah. So when we put, for example, -1 over here, yeah, we display no valid data because the validation works. And if we display 1, the chart and the table is displayed correctly, and some title over here. Okay, so this is the technique for like optimizing our code, not for skipping duplications, but we can find, and we will use later, we will find more like use for reactive values. Now let's take a look at the application, this application again. So we've got the xmax numeric input over here and the title. And if we put some title over here, but the value for x-axis is not correct, for example, we place -1 over here, then anything we put here is just not, it doesn't have the direct action on the application, because it's not actually, it doesn't make sense to place a title here because we don't render anything at all. So the good practice in terms of UX would be to hide this input whenever the value of x-axis x-max numeric input is incorrect. Yeah, so that would be actually better, because the user wouldn't waste time on changing some title if the most necessary part of the applications are incorrectly defined. So how can we do it? We can do it in the we are doing this in the next script, and the function that is responsible for such dynamic hiding and showing up the content is conditional panel. Conditional panel takes two main parameters. The first parameter is the condition that we want to be met in order to display its content. So in the as of the content of our conditional panel, we place the text input, but the condition over here is to have x max value greater than 0. But wait, what do we do here? Why have we been using a dollar every time before, but now we've got a dot here? So the thing is that a conditional panel condition is written in JavaScript. So we need to put some JavaScript over here, JavaScript condition, and in order to access the specific value of the input, of the specific input, instead of using dollar, we use the dot. So it's just the main change that will be suitable for our needs in this workshop. Yeah, so let's try it out. Yeah, we've got title. We put something here, it works. Then let's put, for example, 0. Okay, we've got no data generated, no outputs generated. More to that, we don't have the title. So great. And then come back. So let's define some correct value over here. And what we can see, even if that object disappeared, it still stores its state, the previous state. Yeah. So everything that we've put here before, even if the object disappeared, yeah. And when it comes back, it's over here. That's because the operation for hiding and showing up this object happens directly in the application browser with some proper CSS. And this is a very cool option, because if we want to have such dynamically visible content with some other techniques like render UI and some other things, then we need to send some operation to application server. And with such conditional panels, we do everything on the browser, so we don't use another resources, another RAM memory. So the application should work much faster. So conditional panels works much faster than standard, for example, render UIs if you've used it before. All right. So that's everything for this, and let's move to the exercise. What do we have here? We've got a few changes. The first change is that we've got conditional panel that is checking whether the input $name, so the name text input, if it's not null. If it's not null, then we display the action button, the new action button that we've had before. What else? We've got a reactive value in this application named myTable, and whenever we click Run button, our myTable reactive value is updated, and is updated with taking the first n row, the first rows of iris table, and the number of rows is taken by the numeric input placed over here. Yeah. So, for example, if you haven't seen iris before, it's like the built-in table data frame that is displaying some like observations about the iris, about iris flowers. Yeah. Okay. So we update just the iris over here with having the top rows of it. And then we've got some render table that we, render table. It has some validate need in it with true conditions. So it's always true. So we always generate it and render the table over here. Yes, so this is what happens over here. And for this task, you need to make sure that action button, run action button, is wrapped into the conditional panel and is displayed only when n row is greater than 0. Yeah, so this is the first part of the task. The second part of the task is to update this validate need condition to be sure that the table is displayed only if the my table is not null. So something that we've had before. Is there anything else? Yeah, very important thing. On top of this Shiny application, we load another library, DT. So this offers two new functions to render the tables. So when you replace the table output with data table output and render table with render table, then you will see a new version of the table offered by the DT package. Okay, so your turn and good luck. Mm-hmm. Please don't forget to let me know when you finish. Thank you. So I've checked the questions on the chat. Thank you, Martin, for supporting me. I do really appreciate it. There is a question about the difference between reactive val and reactive values. So Martin already answered this question, but I want to add from myself that it's a common mistake that some people are using the reactive values in the reactive values as the expression, for example, in the observe event for tracking it. The reactive values itself is not the reactive value. So any changes to these reactive values that we can use somewhere will not trigger our computations. We can solve it with another approach that I saw a lot before, is that some people are wrapping reactive values into reactive val, for example, or into reactive. And this is building a little bit complex object that it works, but I think that there are like much prettier solutions. So if you want to keep track of multiple reactive values, just create them, like for example with reactive val, each single reactive val like multiple times, yeah. So each object. Yeah, I think this is better, but yeah, if you like using reactive values, it's also the correct approach. What else do we have here? Why there is a question from Kimberly. Is it recommended to always use reactive val instead of just reactive? I prefer to use reactive val because you've got much more control over it. Yep. So with reactive val, you can specify the initial value, and you have full control when you update it. With reactives, this sometimes depends. So depending on the inputs, sometimes you run some code during the initial flash of the application graph, and then the value is computed. Sometimes it's not. So I just prefer reactive vals because of the control over it. Oh, and Martin also answered it. Yeah, thank you, Martin. Okay, so I think some of the people are already finished. So I think we can move to the next part. And before I do it, let me show you the. I will show you the solution. So up number 3. Yeah, so the conditional panel over here that is displaying action button, and the condition is input.nrow greater than 0. Yeah, we need to remember to put a dot over here in the conditional panels. What happens in the server? Yeah, we change the condition to a negation of isNull function over my table reactive value, and we replace render data table with render data table, and table output with data table output. And let's check the application. So now what we can see is when we generate, our table has the pagination, so that's awesome. We don't need to scroll our application a lot, and it looks much smarter, much more beautiful than the previous solution. So what else? When we provide the number of rows, for example, 0, then the generate button disappears. That's great. So this is a big step to build our target application. And now let's move to the next block. So what do we have here is modal. So what are modals in Shiny application? Modals, if I had to describe them shortly, is the hidden content of the application that is shown when we want it to be shown. But contrary to the conditional panels, the hidden content is displayed on top of the application body. So let's see the examples of it. In this application, we've got 3 examples of modals. So we've got the very basic modal with some content, the plain text over here, and dismiss button that closes it. So this is the modal. We've got the second model in which we've got some text input. So we can put some text over here, and we can even render the text inside. And the third model over here is also the model with some text input. We can put hello over here. We can see that the output of this input, that render text based on this input, is displayed in the application itself. It's no problem to do so. And we've got some custom footer over here, so custom bottom part of the model to close it, like we've added an icon over here. Yep, and that's everything with the models. So now, how can we create them? We create the models in our workshop with using Shiny Gizmo package. Why Shiny Gizmo? Some of you for sure know that models are offered by Shiny itself. The models offered by Shiny are generated directly inside of the server of the application, so it causes some of the problems that we may have to solve. The main problem is that whenever we close the modal, all the inputs included within the modal are deleted. So it's very hard to actually keep track of the state, so to preserve the state of the modal after we close it. We need to put a lot of work to do it. So that's why we are gonna use the modals offered by Shiny Gizmo. In order to create such modal, you use modal dialog UI function, and you can place it directly in the application UI. So let's take a look at the documentation of this. So as a first parameter of modal dialog UI, you put the ID of this modal. Then we can put some HTML content, anything you want, like the content of this modal. For example, plain text, some text inputs and outputs, like we can see in this case, only the text input. You can just treat this as a separate application and put everything inside. Some title doesn't interest us. So button is exactly the button that is responsible for opening the modal. So if we create such modal dialog, instead of its content, we will be seeing this specific button defined over here. And we can turn off such button. For example, it happens in case of the second one with value null. Yeah, in this modal, we just remove the button. So how can we actually open this modal dialog? There is a server-side function responsible for it, named show modal UI. Yep. So where we put as a parameter the ID of the modal. And in our case, we execute this inside of the observer. So open the modal whenever input $open second changes. And what is input $open second? This is the action button that we've placed over here in the application. So yeah, this is another method for opening it. Instead of using the standard button, you can use your custom approach. And the in the third modal dialog, we generate the footer. Our custom footer, we place the action button over here that will be responsible for closing the modal. And why custom action button? Because we want to keep track of the event of closing the modal. Yep. So whenever we want to close the modal, we click the button, its value is updated in the server, and we can use those values. And in order to close the modal directly using action button, we need to do something not standard, but it's not something very unusual. We put some custom attribute to the action button that is named data dismiss and put a value modal to it. So this is like one single exception to do so. And that's everything actually what we do. So shortly, you may treat like modal dialogues as conditional panels, but instead of hiding the content based on some condition, you hide it every time and show it only when you want it, when you trigger it. Yep. And otherwise, everything you write, like the content of the modals, is like you can treat it like writing the standard application. Okay, let's move further. So now let's move to the topic of generating dynamic application structure. So let's check this application that I've prepared here and what the application does. So whenever we click the Add button, we add some new components in the application UI structure. So those are some panels that have some value equal to the current value of Add button. And with this numeric input, we can choose which one do we want to keep track of and click Remove. So we choose which one to remove over here. Yeah, simple application, but it already presents you the concept, like how does it look like in the application to generate the dynamic structure. This is something that Jonas Hagenberg showed yesterday at his first talk on the conference. But I will make a recap and tell you how does this dynamic inputs work. So in the application UI, we've got almost nothing new. So we've got action button, numeric input, and action button. So this is something that we saw a second ago. And we've got the empty div block with some ID. ID is named variables. Now, whenever we click the Add button, we call the insert UI function from Shiny. Insert UI function is responsible exactly for including some content into our Shiny application. So how do we use such function? The first one is the selector. This is the CSS selector that tells the function where to put the new object that we want to add to the application. So what should we remember with CSS selectors? Whenever we've got the block with some ID, like over here div with ID variables, in order to select this object, we need to add the hash sign over here. Yeah, so hash and name of the ID will select exactly this specific div that we've placed in our UI application, and this is where we are gonna place our object, our object in with insert UI. Then we've got parameter where. You've got 4 options over here. We are gonna use before end, that is what is default one. It means that all the objects will be added at the end of this at the end of this element. So within this element, but as the latest element in here. And then UI parameter, this is exactly the UI that we want to include over there. So in our case, we are using well panel. Well panel is like just a single div, but with some class that makes this well panel background visible. Yeah, so we saw the well panels before when I was presenting the dynamic structure. We put some ID over here. ID is actually equal to the value of the input $@, so that we're pretty sure that this is the unique ID. And we put inside of this well panel just the plain value equal to the value of the add button. Excuse me. One last parameter is immediate equal to true. By default, it's false, but we need immediate true in our application in order to insert the UI immediately after we call insert UI. Otherwise, it waits until the next application flash starts. So before which results that before we insert the UI, we will execute some more operations, but we don't want to do it. And later on, if we want to remove the object, we use remove UI function, and we place also selector over here. But please remember that we don't want to remove the whole div. We just want to remove, in our case, the specific well panels. Yeah. So if we precise with the numeric input a specific value over here, then the ID, those are the IDs, yes, the numbers are the IDs of the well panels that we've created, yeah, because we are using the action button values. And then if we want to use the ID as well as a CSS selector, we need to add hash prefix. Yeah, so glue something like this. Yeah. For example, if we provide 1 here, will be the ID of the first well panel, this will be the ID of the second one, and so on. And in order to select the specific well panel, we just use input $which is the ID of the numeric input. Yeah, and that's why we've got this workflow in our application. Yeah. Okay, so now let's move to the next exercise. And let me present what is going on in this exercise. We've got a little bit more complex application now, because this application will be using some dynamic structure. So what do we do is before we actually start our building our application, we define some functions. We define column UI function that is responsible for creating like some tool panel for the specific variable in our target application. Yeah, well panel will be the block of code. It has ID equal to the ID of this function, function that we provide here. Then inside of this well panel, we create modal dialog UI with the standard button. We don't override the button over here. Inside of the modal dialog UI, as the first parameter, we include modal ID, which is the modal prefixed by the ID that we've provided inside of the function. Same here, text input with some dynamic ID, so the ID taken from the parameter. Why is though? Because in our application, we'll be building a lot of such elements. And the general rule in Shiny is that you cannot have the elements that have duplicated input controllers and outputs that have the same ID. That's why we need to put some work to take care that those ID are always unique. Yep, and everything, and for all of the other inputs like action button that has the ID confirm, and some prefix. We've got action button outside modal dialog with ID delete and prefix. And we've got text output with some out name, ID, and prefix. Now, if we have such element in the UI, then we want to generate some logic, server-side logic. Also, same situation here. We want to generate such logic multiple times. So we can place multiple column UIs in our application, but for each such UI, we've got separate logic, we've got separate IDs. So even if this logic will be duplicated, we need to take care of it. Yep. So for example, if you want to generate the observe event for the delete button that is included here, we need to generate the observe event based on this element, but we need to take care of the ID that should be dynamic, yes, at this ID prefix. Same for the confirm, same for the outputs. So a lot of work, but why not if this should work? And for this function, we've got 4 parameters. The first one is the ID. That should be the same as for the column UI. And 3 parameters, input-output session, that we will pass from the server when we're gonna use it. In the UI, there is nothing more. In the server, also not much, but we've added insert UI over here. Yeah, so insert UI is responsible for us to generate in the application the column, the output of the column UI function. We provide some ID here that is dynamically generated with gen ID. I will show you this function in a minute. And we place the second parameter equal to the name placed in the server in name numeric input that is included over here. Yes. So, yes, we've got this. And what is more, we call the column server over here in order to apply the server logic of this component. Yeah, so in order to register the observe events and render the text. What else? Yeah, the second parameter in the column UI that we've passed is responsible for the default value of the name displayed in the model. So let's run this application, check how does it work. So let's put some column name like H. When we click run, it runs insert UI. It inserts the column UI output that we've created. We've got some rendered value over here, the default one. We can open the model. We've got some. We've got the text input over here equal to with the default value of the name of the variable. We can add something here. It works with renders. Yeah. So the server side of this simple component, isolated component works. Then we've got delete that doesn't work, but will work soon. And we've got, what do we've got? Still generate just takes us first and row columns of my iris dataset. Okay, so what is the task over here? The task is simple. The first one is to make sure that delete button, yes, delete button removes the well panel attached to it. So we need to use the proper function to remove well panel, who is providing the valid ID. Remember, this is the CSS selector. And the second part of this task is really simple. It's just, I want you to replace this condition, replace the condition, of conditional panel for run button with the one that I've included over here. So good luck. And please let me know if you have any questions. Please remember to Please remember to let me know when you're finished. Funny, Ivis, but sometimes this happens. Let's try to change the ID. All right, Fabio is ready. Let's wait for the others. If you have any troubles, just please ask on the chat, or you can always take a look at the next script that is storing the solution if you have troubles with it. I can see now that more people finished. So let me quickly present to you the solution. So what is the solution? The first thing we wanted to do was to remove the wheel panel whenever we click the delete button. So if we want to delete it, we just use remove UI in this observe event, and we use the exact ID passed to the function because this was the ID of the well panel. But we remember this is the CSS selector, so we add hash prefix to it, and that should work. And regarding the condition that we've placed, the condition is taking the all the div objects inside of our variables container, so the container where we place the well panels, and is counting them, and whenever the number of those elements is greater than 0, then we display the run button. So this is like another UX improvement that we wanted to add to our application in order to make sure the user doesn't click generate if the columns are not defined. Yes, so that's what the condition does. And now let's move to the next part. But before we do it, let's come back to the application we've had in the previous exercise. So what did we do here is like we implemented the well-known component of Shiny applications, what is Shiny modules. So in order to create the dynamic elements, dynamic structure, we've implemented the column UI function, and we took care of having unique IDs over here, and the same thing we've done within the server part of this component. But Shiny allows us to do it much easier. So here is the version of those components, of this component, with using Shiny modules. So how do we build Shiny modules? At the beginning of the UI part, we always place such line of code. What does it exactly do? So if we provide some ID to the capitalized NS function, so for example, my ID, it generates another function. So if we use this function, for example, on modal string, it just adds the prefix. So exactly this is something that we've implemented before, yes, but instead of underscores, we use dash here, but the NS function adds like the ID prefix to our inputs. Yes, so for example, now if we want to generate the dynamic UI, like a dynamic ID for the UI part, every UI that we use either for inputs, modals, or outputs, we wrap into this NS function. And with this, we're pretty sure that whenever we call this function multiple times with different IDs, the IDs of the specific components will be different as well, will be unique as well. Now, regarding the server, if we want, actually regarding the server, we've got much more improvements. It's much easier comparing to our approach, in which we also had to take care of the unique IDs. So if we want to define the server function, we create another function of ID parameter, and inside of this function we call module server function from Shiny. The first argument of this module server is the same ID, and the second one is the function responsible for defining the server logic of this component. And what happens in this component? Now the work over here is much easier. We don't need to care about adding those prefixes because Shiny does it for us. Yeah, like for example, accessing the delete button, listening to the delete button, we may use as if we were working in the standard Shiny server. Yeah, and this module server function does it for us. So this is like much easier than to write it. We don't need to care about adding those namespaces. Inside of this example, we've added also one more thing. So every time we call the column server, we run show modal UI. That will be automatically opening as the model right after it's created. And What else happens in this module, in the server part? We are using the function that I haven't described before. It's reactive values to list called on the input. This is pretty useful feature of the Shiny module, that the input object in module is different than the input object in the server. So what is the difference? The input object inside of the module stores only the inputs included inside of this module. So taking all the inputs and converting them to list with this function allows us to take all the values that we've had in the module provided by the users. So that's pretty useful in order to use later on the specific values in this select module. And that's it. So let's take a look at this application if this works. So we've got number of rows, column name, add button. We can see that if we click the add, the well panel regarding the column configuration is added. The modal over here is automatically open. We've got the possibility here to modify the name of the variable. And we can generate the table that is still the iris one. And what we can see in the console is exactly the list of all the inputs included in this module. So in the observe event that it was tracking to closing the modal, we print reactive values to list of the input. And what we can see here is the name value equal to the name that we've placed there, confirm button, so the value of the confirm action button, and value of the delete action button, which we can, for example, remove if we don't want them what is happening later on. Okay, now we have one. Now let's run the application again and see one thing that we can improve. If we place something here, let's stay with the H, and close the modal, what we can see over here is that the column name still persists, the previous one. And if we are speed clickers, then probably we will click this button again and create another H variable, which is that something that we don't want to. So we've got two options. The first option is to somehow check over all the existing variables and disable the add button whenever the variable already exists. But the second thing, which is a little bit worse but presents one important part that I want to describe to you, is communication, is clearing up this text input. Yeah. Then somebody, before creating new column, have to put something here, and if we know what the application is going on, we can place some other text or place H again, which is usually something that we don't want to do, but it's not the case over here. So how can we do it? We already know how we can update the inputs. So with update text input function, yeah, this is the update function related to the text input. So what could we do is to actually, whenever we close the modal, we do update text input. What's over here? Session, yeah, and input ID is what ID do we have for the name in the server? It's name. Okay, so let's name here, and the value should be empty string. Yeah. So let's run this application, check what's going on. Let's add new variable, and we expect that whenever we click confirm, this name input will disappear. Oh, what happened? Why this disappeared and not this? Because we've got also name here. This is the first thing. Yeah, the name input inside of the column UI, inside of the UI of our module. But even if we remove this, if we don't have this, it won't work. Why? Because the update text input is operating on an isolated namespace of the module. So when we call update text input, the Shiny understands that this name is related in fact to the ID-name, so the namespace of this module. So how can we actually go outside of this module and do some operations on the global name input? So there are again a few approaches, but I will present to you the one that is the most straightforward and the easiest one. So let's open the next script, modules communication, and over here in the server we've got the line 68. We've got usage of session $user data object. So this object is shared across all the modules and standard application server. So we can use it to actually pass some information between modules and between the server and from the server to modules. Yeah. So let's do it. And how can we actually use it in our case? In this session user data, we may create anything you want, any R object you want. So you may create a static list, data frame, or reactive value. And this option will be used by us. So we create the object named module clause as a reactive value with initial value equal to 1. So all right, so what do we do now? Then if this value changes, so we've got observe event for this value, then we want to update text input with input ID name. Yeah, and because we call it directly in the server, it will take this name, this text input defined directly in the application UI. Okay. But now we need to somehow trigger changes of this reactive value. How can we do it? Very easy. Yeah, inside of the server of our module, we already observe closing the modal. Yes. So whenever we close the modal, we take the previous value of our reactive value, we increase it by 1, and update this reactive value. And then then the main application server will trigger the observe event that will be responsible for updating the name, so clearing the name. And let's try it out. Page again, confirm, and this is cleared out. Yeah, so that's great. We've managed to communicate from module to application server and do some applications globally, some operations globally. Now let's move to the exercise. What do we have here? So let me explain something that already showed up before. So we use the line of code source tools.r. This tools.r is the script in which we've got some useful functions that I'm using later on to build the target application. So one function we've already been using, it's gen ID. So this generates us the random ID. So whenever we call it, we generate random ID. So this is what we were using to generate the random ID of our module. Then what do we have? We've got getState function that is taking the input argument, and this getState function is using reactive values to list. So we are taking all the inputs that are existing, for example, in the module, and then return only all the elements except for confirm and delete. So this is the value of confirm button, and this is the value of delete button because we don't want it. Then there are a lot of functions, like 4 functions that are taking the state of the module that we'll be seeing soon. and are responsible for generating some columns. So for example, gen_call character, it's generating us the character value, numeric, integer, custom for parsing the code that we've provided, which we shouldn't do, as I said. Then column, that is responsible for taking the type of the column and then call the proper function. So it's just a useful function to select the correct generating function. And gen_table, this is the function that we will be needing in this exercise. It takes two arguments. The first one is the states. So this is the list. States is the list of the column configurations. Yeah, so this is exactly what we saw in the demo application when I've been clicking through some configurations and then generating the column based on it. So here we pass all the configurations for all the columns we have, and as a second parameter we put the number of rows, and then some magic happens over here. This is the pure mapdfc function that is like just the function to iterate over the list. Now about the edit panel UI. Do we want it now? Yes, we want it now. You want it now? Yes. Okay. So edit panel UI and edit panel server are the functions. This is exactly the Shiny module that you could see in the demo application. So when I clicked the column configuration, you could see a lot of inputs. You probably, you even can see now there are a lot of conditional panels over here. So everything that is here should be already understandable to you, but we will not be building this on our own. Yeah, because this requires a lot of time to think about what we want to show and when, what we want to include, and so on. So I've created this for you, and the same for panel server. We are not gonna build it, but I will shortly explain to you what's going on over here. So in this edit panel server, we save the state as a reactive value and update it whenever we close the configuration model. And we update it with using getState function that I presented you before, that I described before. So whenever we close the model, we claim that we accepted the configuration, update the state of this specific module, and send it outside of the module with session user data. So now let's check the exercise. What do we have in this exercise? At the beginning of server, we create session user data vars. This is the standard list, not the reactive one, but just the standard list object. We've got another object that is in the session user data that is named clear, and this is the reactive value. And this is exactly what we've done before for clearing out the input for column name. Yes. So then what do we do is in observe event, whenever we click the new button, we add the edit panel UI. So this is that big chunk of code that I've showed you before. So the configuration panel. We call edit panel server over here to trigger to register the server part of our module, and actually that's all that has changed. Yeah, we've got the clear for clearing the input. Yeah, one thing is that this global object, this list, is updated with the state of the module whenever we close it. Yeah, so then we can use session user data vars as the list of column configurations. Yep. What's more? We've got observer for delete button. When we click delete button for the specific column, then we need to clear the column configuration. Yeah, so that's we reassign this to this value, the null object, and then we remove UI so that we remove this well panel. Yeah, so let's take a look at the application. Column name plus Yeah, we can see this is something that I've already shown you. Yeah, H. If we click delete button, it's removed, works fine. What else? We've got some character. And we click generate and nothing happens. Why nothing happens? Because this is your turn to actually make it work. Yep, you need to find where the observer for generate is, and you need to use genTable function from tools R that will be generating the target table, the final table, and updating the rest table object that is the resulting table we want to use. Yep. So let's find the correct observe event and then generate the table and update the rest table with those generated table. And please, as usual, let me know when you've finished. Then we'll be able to move to the next part. There is one question from Coffee regarding putting something like this inside of the module server. So when I've got module server, for example, here, yeah. So sometimes you may see, I already have it. You may see that inside of the module server, we do something similar to the UI part. So to create the NS function, you can get from the session object the NS function relating to session $NS. In some cases, you may need to use it. So what are those cases? For example, if we decide to create the well panel ID with using also namespace, like using the NS, then we will have to also use it inside of the remove UI because it's not taking care of the session. How to know whether the function takes care of the session or of the namespace of the session or not? Actually, the easiest method is to try out to do some tests, because then you will get the intuition about when it works and when it does not work. So usually you may think that it does not work when you place some IDs that are not the exact Shiny IDs, like the input IDs, output IDs, and so on. So for example, the specific CSS selector needs to be properly defined in order to make the Shiny browser understand that we want to remove exactly this element. So this is like not the direct answer, but yeah, the direct answer is you need to test out when to use it and when when not. For example, one function didn't work is show module UI from Shiny Gizmo. So previously you had to put here the model ID namespace by yourself. But we've installed the development version in which I fixed it. And so now it works fine with modules, but previously it was not. Yep. Okay. So how are you doing with the exercise? Yes, if you use the namespace in the server of the module, like this ns function created from session, taken from session that we could see, where was it? We could see it here, if I'm right. Give me a second. Oh, if we, for example, use namespace over here, for example, for input ID, then it won't work. Yeah. So we need to skip this namespace for the inputs, for outputs, and for some of the functions. But yeah, as I said, I cannot tell you about the full set of functions in which it works and the full set of functions in which it doesn't work. For sure, if you sometimes you will have to use it in remove UI if you also add the namespace in the UI for the well panel. Yeah. In our case, we didn't add the namespace for the well panel. It was exactly equal to the ID of the module. But if we made it also dynamic based on the ID, like with using namespace, then we will have to use it in the remove UI. Like then we will have to use it something like this. But this is not the case over here. We didn't add the namespace to the ID of the well panel. Okay, so let's move on. As Muriel asked, so shortly, how can we solve the issue? Solve the exercise? We use gentable function, yeah, and as the list of the states, the columns configuration, we put session user data vars, and as a number of rows, we put the input $n row. So this is the number, the input that we create on top of the application, and we update REST table with it. And that's actually everything we had to do. And then if we run the function, when we run the application, we place some variable, yeah, for example, integer, and click generate, the column is generated. All right, so now let's quickly check what do we have in the latest part. I wanted to tell you about REST API in using REST APIs in the Shiny application, but we'll skip it. We won't skip adding the CSS. So if we look at the www directory, we've got the simple.css file. This is the CSS file that provides only a few rules, the CSS rules for the current application, for the application. So whenever we, for the body object, we change the background color attribute. For form.well, this is the form element with well class. We also change the background. Also, we change the background for all well panels. Those are the divs with well class. We change the background color and border radius. This is the radius of the corners of the elements of the well panels, and every button in our wells have also some rounded corners. And how do we attach the CSS file to our Shiny application? It's just enough to put the inside of the tags $head in our on top of our fluid page. the following code. This code looks always the same except for the href parameter in which we place the name of the CSS file. And what do we need to take care of to know is that www is the specific folder of Shiny applications that is treated as the top directory for our resources. So we don't need to actually provide www over here. We just put the name of the file inside of this directory. And with this, if we run the application, we can see that in the application, we've created the 2 well panels. Inside of each well panel, we've added some action buttons. And as you can see, with just plugging a simple CSS code, we've changed the look of our application. And now, for the last exercise, I planned to attach some JavaScript and CSS to our Shiny application. But instead of doing so, I will just, because we've got 3 minutes, I will just show you how it should be done. So, we are adding we are adding the JavaScript script to our Shiny application with just a single line of code. So this is very easy in Shiny, and this JavaScript code I've already prepared for you, and custom CSS that is the final styling for the Shiny application. And if you just plug it in here with just 1 line of code, you can totally change the look of your application, of the application that we have. Writing CSS is not easy. For some people it is. For me, it's not super easy. I don't do it a lot, but this CSS I did by myself, and I'm quite happy with it. It looks quite nice, as for me. Yeah, and cool thing is that if you open the developer Chrome panel, you can do it by pressing F12 and look at the Elements tab. You may think something like this: root, and you've got 4 variables. So with changing those values, you can easily change the look of this Shiny application that we've built together. Yes, some of the variables over here are responsible for different parts. Maybe this bright one, let's make it yellow. Yeah, to make something like this. So you can play with it. You can analyze the CSS code if you want, try it out to implement some changes, and that's all. So if you have any questions, just let me know. You can catch me via LinkedIn, on GitHub, and anywhere else you can.
Yeah, definitely they will.
Facebook everywhere. Yeah.
Yeah, I saw that that workshop like create a lot of interest among our users, and I can totally understand this. It was really nice delivered. I love the idea of like adding step by step more concepts to the same application. So yeah, please take a look later, probably on this repository, and maybe recap what was there in your own
Exactly.
pace. Yeah, thank you, Krystian. Again, that was excellent. And
thank you, Marcin.
yeah, I
thank
guess
you,
we
everyone.
all deserve some break right now, so you can feel free to join some networking sessions and grab a coffee. Ahead of us, there is a really nice group of talks. So there is Eric will be speaking, John, and we will finalize with the keynote, How Shiny Taught Me Web Development, from Jacqueline Knowles. So see you soon. Take your time for some break or networking, and let's come back for other talks. Thanks you again, Krystian.
Thank you.